This is our first question. If zeros of x square plus 4x plus 2a are alpha and 2 by alpha, then find a. See, here the zeros are given as alpha and 2 by alpha. We know the product of the zeros. That means normally we take alpha, beta are the zeros. Okay, normally we take these as the zeros. So alpha plus beta is equal to minus b by a, and alpha beta is c by a. This is what we know. And here in this question, alpha is there as one of the zeros, and the second one, that is beta, in place of beta we have 2 by alpha. So if we take this property, that is the product of zeros is c by a, we can solve it easily. See, the product of alpha and 2 alpha, what we will get? Alpha into 2 by alpha is, we can cut this alpha and alpha, that is 2. So what we got here is the product of two zeros is 2, which should be same as c by a. In the given expression or in the given polynomial, in place of c we have 2a. So c by a means the coefficient of x square. In this expression or in this polynomial, in place of a we have 1. So 2 by a by 1. Here it is 2. Got it? The product of two zeros is c by a. In the question, the zeros are given as alpha and 2 by alpha. When we multiply them, we get it as 2. And from this polynomial, in place of c we have 2a, and in place of a we have 1. So it is 2a by 1 is equal to 2. That means a is equal to 1. This is our second question. Find the quadratic polynomial whose sum and product of zeros are 21 by 8 and 5 by 16 respectively. So sum and product of zeros are given. Then we know we can write the polynomial as p of x is equal to x square minus alpha plus beta into x plus alpha beta. Here in this question, the sum of the zeros alpha plus beta is given as 21 by 8 and alpha beta is given as 5 by 16. So we can give these two values here. So we can write it as x square minus 21 by 8x plus 5 by 16. Okay, we can stop by this, or we can multiply throughout by 16, like this is same as 1 by 16 into 16x square minus 42x plus 5. Our third question. If m and n are the zeros of the following polynomial, see this is the given polynomial, then find the value of m by n plus n by m. So what is asked is m by n plus n by m, where m and n are zeros of the polynomial. Now let us do cross multiplication over here. M into m plus n into n, like that. So it will become m square plus n square divided by, when we do the cross multiplication we have to multiply the denominators here, right? So it is m n. And let it be there, because what we have to find is this, and what is given actually, we know this is the given expression, and from here in place of a we have 3, in place of b we have 11, and in place of c we have negative 4. So m and n are the zeros of the polynomial. Sum of the zeros m plus n alpha plus beta is minus b by a, and here it is minus 11 by 3. And product of zeros m n alpha beta is c by a, here it is minus 4 by 3. Okay, so c by a became minus 4 by 3. Okay, so from here what we get is m plus n is minus 11 by 3 and mn is minus 4 by 3. We can apply our apply these values over here. But here we have m square plus n square. So we have to do some changes here. See, m square plus n square can be written as m plus n the whole square minus 2mn, right? By mn. Mn is already there in the denominator part. See, this is a plus b the whole square identity. A square plus b square plus 2ab. That means we have to subtract that middle term minus 2mn. That is why we subtract the middle term here to get m square plus n square. Got it? I will explain once again. See the identity. A plus b the whole square is a square plus b square plus 2ab. Right? Here we have only a square plus b square in the question. See, here we have only the sum of two squares. So a square plus b square. In order to get that, we have to take that 2ab term, okay, to the left. So it will become a plus b the whole square minus 2ab. That is what we have done here. Now we know the value of m plus n and mn. We can give these values in this. So m plus n is minus 11 by 3 the whole square minus 2mn. 2 into minus 4 by 3 divided by mn minus 4 by 3. This is our final answer. So minus 11 by 3 the whole square minus 11 by 3 into minus 11 by 3. See, when we multiply a negative number 2 times, or when we take the square of a negative number, the final answer should be a positive numbers, right? So 11 square is 121 and 3 square is 9. So it is 121 by 9. And see the next term, minus minus. See, two negatives are coming together, so it will become plus. Plus 8 by 3. 2 into 4 became 8 and 3 is over here. And we have to divide it by minus 4 by 3. Now, see, here we have a 3 and here we have a 9, right? We can make this 3 into 9 easily, right? See, 8 by 3, we need 9 as the denominator, means we have to multiply by 3 to make the denominator 9. So we have to do the same thing with the numerator as well. Here also we have to multiply by 3. 8 into 3, 24. So we can write it as 121 by 9 plus 24 by 9 all divided by minus 4 by 3. Okay, now in the numerator part we have two fractions. We have to add them. Okay, so 121 by 9 plus 24 by 9. Both the denominators are same now. So we can just add 121 and 24. That is 145. 145 by 9. Okay, so the numerator part is 145 by 9. And in the denominator we have minus 4 by 3. Now denominator is numerator. That is, this 3 will go to the numerator part. And this 9 will go down, right? So 145 into 3 by minus 4 into 9. Okay, see here we can cut this 3 and 9. And we have a negative sign in the denominator, so final answer is negative. Minus 145 by 4 into 3. Okay, so again we cannot divide this, right? We don't have any common factors. So we can just multiply the denominators. So what we get is minus 145 by 12. That is the required answer. This is the fourth question. If P, Q are the zeros of this polynomial, then find P square plus Q square. So P and Q are the zeros. Anyways, P square plus Q square is P plus Q the whole square minus 2PQ. Just because this is from an identity, as we have done it in the previous question. So why we have turned it like this means we can understand, or we can calculate the sum of the zeros and product of zeros from this expression itself. So alpha plus beta is actually P plus Q. and it is minus b by a. And here from the expression or from the given polynomial, in place of a we have 2, in place of b we have minus 7, in place of c we have 3. So we can substitute these values over here. Minus b by a minus of minus 7 by 2. That is 7 by 2. This is what is p plus q. And similarly, we can find the value of PQ like alpha beta. Alpha beta is C by A. That is PQ. In place of C, we have 3. So 3 by 2 because A is 2 over here. Now we got the value of PQ and P plus Q. We can give these values over here. So P square plus Q square will become P plus Q 7 by 2 the whole square minus 2 times PQ. PQ is 3 by 2. Here we can cancel this 2. So it is 49 by 4. 7 square is 49. 2 square is 4 minus 3. Now here we have to subtract a whole number from a fraction. See here we don't have a denominator, right? So we have to cross multiply. So in the next step it is 49 minus 4 into 3, 12 divided by 4. 49 minus 12, 7 over here and 3. So 37 by 4 is the answer. This is our fifth question. Find the condition that zeros of this polynomial are reciprocal of each other. See, reciprocal of each other means if one is alpha, if one zero is alpha, the other one is 1 by alpha. This is in place of alpha and this is in place of beta. So alpha beta will become alpha into 1 by alpha, that is 1. Got it? Here the zeros are reciprocal to each other, means if one is alpha, the other one is 1 by alpha. So when we multiply them, we should get 1. And we know alpha beta is C by A. C by A is equal to 1. That is the condition at which the zeros are reciprocal to each other. So C by A is equal to 1 means we can conclude it as C is same as A. This is the condition. This is the answer. This is our next question, sixth one. Find the value of k if minus 1 is a zero of the polynomial. Okay, minus 1 is a zero means what? P of minus 1 is equal to 0. And P of x is given here. In order to get P of minus 1, we have to put minus 1 in place of x here. So k into minus 1, the whole square minus 4 into minus 1 plus k equal to 0. Listen, whenever we write the value of that or when we substitute the value in place of x, we have to put a bracket, otherwise negative and square, all these things will get mixed up and see kids will miss the answer. Okay, so minus 1 the whole square is 1, so it is k plus 4 plus k equal to 0 because minus minus, see two negatives together it is positive, so k plus 4 plus k is equal to 0. K plus k2 is 2k plus 4 equal to 0. That means 2k is equal to minus 4 because we have to take this 4 to the other side. Positive 4 became negative 4 on the other side, so k is equal to minus 4 by 2, that is minus 2. This is our seventh question. If alpha, beta are the zeros of this polynomial, then find alpha plus beta minus alpha beta. See here, in place of A, here we have 1. In place of B, we have minus 4 root 3. And in place of C, we have 3. So alpha plus beta is minus B by A. So minus of minus 4 root 3. We have to give that negative sign as well. See, B is negative in the given polynomial. So minus of minus 4 root 3 divided by 1. That is positive 4 root 3. And alpha beta is C by A. That is 3. So we have to give these values. Alpha plus beta minus alpha beta is what we have to find out. So alpha plus beta is 4 root 3 minus alpha beta is 3. This is the answer. So 4 root 3 minus 3. This is enough. This is our eighth question. If alpha, beta are the zeros of this polynomial, find k if alpha square plus beta square is equal to 40. So, as we have discussed in the previous questions, now this is coming from an identity a plus b the whole square. So, a plus b the whole square minus 2ab will give us a square plus b square, right? We have already done it in the previous questions. So here in place of a, see, by comparing the coefficients, a is 1, b is -6 and c is k. So alpha plus beta is minus b by a. Here in place of b we have -6. So minus minus, right? So minus of -6 by 1, that is +6 is the value of alpha plus beta, and alpha beta is c by a. That is in place of c we have k and in place of a we have 1. So it is k. So these are the values of alpha plus beta and alpha beta. Now what we have we are given is alpha square plus beta square is given as 40. So alpha square plus beta square is given as 40. That means what this implies, alpha plus beta the whole square minus 2 alpha beta is 40. Got it? From where we got it? See, from the identity we can write it like this. Alpha square plus beta square is alpha plus beta the whole square minus 2 alpha beta. Now we can give the values. See, alpha plus beta is 6. So 6 square minus 2 alpha beta, it is k. So 2k is equal to 40. Now what we have is 6 square 36 minus 2k is equal to 40. So minus 2k, see minus 2k is here and we have to take this 36 to the other side. So it will become 40 minus 36, that is 4. So what we have now is minus 2k is 4. So k is 4 by -2, that is the final answer or the value of k is -2. This is ninth question, the last question in this video. If one of the zeros of the quadratic polynomial, this is the quadratic polynomial, is negative of the other, that means one zero is negative of the other zero of the polynomial, then we have to find k. Okay, normally we take alpha beta as the zeros, right? And we know alpha plus beta is minus b by a and alpha beta is c by a. And here what we have mentioned is one of the zero is the negative of the other. So in place of alpha, if we take it as alpha itself, in place of beta, we have minus alpha, right? One of the zeros of the polynomial is just negative of the other. So these two are the zeros now. Then what happens to alpha plus beta? See, alpha plus minus alpha should be 0, right? That means sum of the zeros minus b by a should be 0. Got it? Alpha plus beta is the sum of zeros, and in the question, one of the zero is negative of the other. So when we add a positive number with its negative, we should get a 0. That means sum of the zeros of this given polynomial is 0. Hope you understood. So minus b by a should be 0. In place of b, we have what is here given. In place of b, we have minus 42k square, and in place of a, we have 14. Right? In place of a, we have 14. So minus b by a equal to 0 means what? B is equal to 0. Right? B should be equal to 0. And in place of b, we have 42k square. Okay, minus 42k square is 0 means what? K should be 0. So that is the value of k. Thank you. Hope all of you have understood.